If you've done a lot of work in Helm, you know that it heavily depends on YAML file templating, but it's kind of a wonky process. And today I've got two folks with us here on IBM Developer Tech Talks that have got a new tool that makes that a lot easier. Hi, I'm Calvin Powers. I'll be your host today here on IBM Developer Tech Talks, and we're going to be talking about the YAML templating tool. We've got two presenters today. First, we have an IBMer, Nima Kaviani, sorry, who is based in the San Francisco area. Nima, welcome. I think this is your first broadcast on IBM Developer Tech Talks.
It is indeed. Yes, thank you very much. Happy to be here.
And then our second presenter today is back for his second appearance, Dmitriy Kalinin, and he is with Pivotal. Welcome back, Dmitriy. You're like a veteran now.
Thank you very much for having me again.
Before I let these folks take over the airwaves, it's my job to do a little bit of housekeeping. If you're watching on our YouTube page, you'll notice there's a chat window to the right of the player window. If you have any comments or questions for Nima or Dmitry during today's webcast, type them in there. I'll be monitoring that chat window, and I'll either ask your questions immediately or hold them to the end as appropriate. So don't be shy. Feel free to share your comments and questions on the YouTube chat. The other thing I want to point out is that in the description field below the YouTube player, you will find a link to today's event page. And the event page is where you will go after the presentation today to watch the replay. And we will have all of the important links that are mentioned on today's presentation so that you can get all those links very easily. So do yourself a favor, after today's event, go to the event page there in the description field below the window. All right, I believe Nima's going to start us off. So what you got for us, Nima?
Sure. Let me start by sharing my screen so that I can get the slides going. And then can start. Great. You guys see my screen?
Absolutely.
Perfect. Let's go to the presentation mode. All right. Thanks again, Calvin, for having Dmitry and I on this webcast. So as I mentioned, my name is Nima Kaviani. I'm an engineer with IBM, and Dmitry, my colleague, is an engineer with Pivotal. And the two of us have been working on a number of different projects. We've been releasing a good number of them under the K14S GitHub organization, which stands for Kubernetes Tools. So for anyone out there, if you're interested in deploying applications to Kubernetes, check out the tools that we've released and let us know what you think. We definitely would love to hear your feedback. All right, so let's get to it. Deploying applications to Kubernetes. So if you've done application deployment to Kubernetes, you know that once you have written some code and you've packaged it in the form of Docker images, then you need to write some configuration files, which basically tells Kubernetes what resource objects it needs to create in order to get your application up and running. And these configuration files are often written in YAML, in the form of YAML documents. And you need to do some preparation and some tuning of these YAML configurations. For example, you need to decide on the number of your application instances, the passwords that your application are going to require, and whether or not it's going to use load balancer, etc., etc. And once you've done all this tuning, then you apply your configuration to your Kubernetes cluster and you get your application deployed. Then after a while, you need to do some more modifications, let's say increase the number of instances. And then once you've made the changes, you reapply and you essentially repeat this cycle. So the one part that is interesting in this flow from the YTT's perspective is the preparation of these configuration files that you do. And if you've been around in the Kubernetes environment community, you know that the community has chosen a number of different approaches to do templating of, to do configuration modifications for Kubernetes objects. One approach is using the templating tools like Go text templating or Jinja. Another one is to use the overlay tools like Customize, or there are specialized configuration languages like DAL and JSON that allow you to do this, or full-blown programming frameworks like Pulumi. So I'm going to go over each of these one by one and further talk about, basically motivate the needs for having YTT. So templating, as Calvin mentioned, Helm is one of the primary tools that we use to deploy Kubernetes applications. And what Helm does for templating is that underneath it uses Ghost text templating engine. And the way it works is that you have your YAML configuration document, you add some directives, some computational constructs in the syntax of Ghost text templating language to it. And then once you pass this configuration file, this templated configuration file to Helm, then Ghost text templating engine kicks in and converts your templated in YAML document to an actual YAML document, applying the configurations and the data that you've passed there. But obviously, one of the biggest problems with it is that because the language that Go text templating uses for its templating is different from the YAML documents. Obviously, the templated document diverges syntactically from an actual YAML document. And also, the templating engine treats the entire document as text. So it doesn't understand anything about YAML. It doesn't understand anything about the syntax of YAML. And as a result, you as a developer need to manually account for these syntactic indications and requirements in a YAML document. You have to do the indentations manually. You have to escape the characters manually. So it's quite challenging. And that was one of the primary reasons we started thinking about an alternative. In the early days when we were deciding what, developing YTT. Another category of tools are the overlay tools. And if you're familiar with Kustomize is one of the primary ones in the Kubernetes community. And the way the overlay tools work is that they treat these YAML configuration files as the base configuration. And then they allow you to add layers with variations on top of these base configurations. For example, you can do more surgical changes to your YAML documents. You can remove elements, you can add elements, you can replace elements. But these languages are more constrained in the sense that you do not have the full power of, like a programming language, like loops and conditionals, in order to be able to have all the conditions for all your users or consumers in mind when you define the overlays. So developing overlays to target a large audience is difficult. A third category are specialized configuration languages like DOL and JSONet. And what these languages do, they actually provide like a very specialized language for you to define your configurations in. But obviously, them being specialized languages implies that now you need to learn a new language, which adds a little bit of barrier to getting on board with these configuration languages. And also, because these languages are very special purpose, oftentimes there's not enough tooling around in order to be able to develop configurations in these languages. And finally, the last category are full-blown programming frameworks like Pulumi. And very much like the specialized languages for configuration, these are also full-blown frameworks that have their own libraries that you need to use. But onboarding and getting started with these frameworks is complicated. Also, now the process of configuring and deploying your application moves away from being declarative and becomes more imperative. It's as if you're writing code to deploy your code, which is of course harder to comprehend and make sense of, especially if you're new to the framework. So with all of these, we decided that YTT can potentially basically introduce like a new angle to it, where it actually allows you to do templating and overlaying, but also in a way that is more understandable and easier for people to get a hold of. So rather than having templating versus overlaying when it comes to dealing with configurations in Kubernetes, what YTT decided to do was to combine both under one engine. So in order to do so, we actually identify two different group of stakeholders as the primary stakeholders when deploying Kubernetes applications. One is the group of stakeholders are the configuration providers. And these are the authors of configuration files and the authors of the applications that you want to deploy to your Kubernetes cluster. You can think of them as those who provide like help charts for particular deployment. And these group of people, because they provide templates to their consumers and customers, they need to support a wide range of audience. So they need to be able to have their templates designed in such a way that it can accommodate the needs from different group of peoples. And for that reason, they need more powerful computational constructs and language constructs to, allow this flexibility. They need things like loops and conditionals to define and implement their configurations. And as a result, we believe these are the group of people who may require templating of the configurations for the software they release. The other category of people are consumers of these templating files and configurations. And you can think of them as users who deploy particular Helm charts in the Kubernetes world. So what they do is that they basically pull the configuration files from the upstream and then apply their tuning and deploy it to their Kubernetes cluster. But over time, what happens is that they run into situations where the original providers of these configuration files haven't envisioned a particular need in the deployment of the software. So they need to more surgically go in and like add stuff or remove stuff. And we believe for this category of people, overlaying configurations on top of the base configurations that are provided by the upstream makes sense. And that's why YTT combines the approach of templating and overlaying into one tool. So this is a quick example before I get into the details of YTT. And as you can see, you can download, for example, the Nginx configurations from the upstream. You can pass in your input with the data that you want to apply when you deploy your configuration. And then you can add another layer of overlays to tune it exactly to the type of deployment that you want for Nginx. So what is YTT? YTT is a structure-aware templating language that understands the YAML structure. So it's not dealing with the configuration files as text. As a result, you don't have to worry about indentation or escaping of characters because it does it for you. YTT uses a Pythonic language for templating, which we believe makes it easier for people to onboard because there is a larger group of people who are familiar with Python as a language of programming rather than a very domain-specific language. The idea for YTT is that it still tries to be declarative, but also supports the imperative operations like loops and conditionals. So it allows you to be more flexible when you write your templates. It allows for modularization and configuration of structures. You can split your configurations and templates into libraries, and you can import them into one another and reuse them. It allows for data injection using the overlays, so it targets and it addresses the needs of the consumers of the templates. And it also allows for data validations, like assertions, so you can verify that the data that is supplied by the users is of the right format, for example. So with that, like a quick motivation and a high-level introduction of YTT, I'm going to pass it to Dmitriy, who's going to get into the details of how YTT can be used for configuration and templating.
Great. All right. Let me share my screen. All right. Hopefully you all can see.
Hello, hello? Dmitriy, you're frozen.
Yeah, I think he's frozen.
All right, we'll give him a few seconds.
Sure.
Nima, while we're waiting for Dmitriy to recover, hold on a second. Dmitriy, if you can hear us, drop off the video call and join back in. Oh, wait, is that, hello, hello?
Yeah, I think like the Google Hangout crashed his Mac, so he's rebooting it. I think we should probably just give him a few seconds.
Yeah, yeah.
While
we're waiting on Dmitriy to get back in the loop, if people try this tool and they have comments or questions or suggestions, what's the right way for them to reach out to the two of you with their ideas?
That's a very good question. So first of all, like in the Kubernetes Slack community, we have a channel called K14S. So they can come to the K14S channel in the Kubernetes Slack community and ping us there. Also, they can file issues or submit PRs on GitHub. It's a completely open source project. It's available under github.com K14SYTT. And we would love to hear feedbacks and contributions from the community.
Sounds good.
So definitely.
So that's the K14 Slack channel as well as the opening up issues on the GitHub itself. All right.
Yes, K14S.
K14S. Okay. Dmitriy, it looks like you're back. You want to try again?
Yep. Funny how live demos happen.
I know. So we were on this call 20 minutes before we started, and not a hiccup. Anyway, it looks like we got your command line up now, so that's good.
All right, perfect. Well, actually, you know what? Let me start out from the browser over here. So as Nima, I think, mentioned in the slides, get-ytt.io is the website, the homepage for the project. There is a GitHub repository, but what's interesting about this website is it actually has an interactive playground where you can actually use YTT without having to install it. And that's actually a great way to play around with it, see if some of the things make sense that are presented in YTT. If you want to continue on, you can of course go in and install a binary on your machine and play around with your own YAML files or make some new ones. So I thought that we would go through some of the examples that we show in the interactive playground over here, and to kind of familiarize people with how YTT actually works and how you get to use it. So the first example over here I have is a plain YAML example. As you can see over here on the left side, we have an input YAML file. There's a file name over here, YAML.yaml. And then on the right side, we have the result of the processing that YTT would do, right? So on the command line, you would type in something like YTT-f YAML.yaml, and then the standard out from that command will be what's presented on the right. So as you can see over here, YTT actually just processes regular YAML files. One exception to this rule, though, is it does not like when you use regular comments. And the reason why it doesn't like regular comments is because YTT relies on metadata stored in YAML comments to assign certain meaning to certain things. So for example, here we have all of these comments that are pound exclamation mark as the regular YTT comments. As you can see over here, all of these other values and all of the other data nodes in YAML are preserved. Another thing you may notice actually that the order of these keys remains the same, which if you've used some of the other tools out there, you may actually notice that the order keeps on being sorted alphabetically, right? So we've done that to make it a little bit friendlier to track down where the data values come from and whatnot. All right, so I'm going to assume that most people are familiar with how YAML looks like and different types of YAML structures involved. So I'm going to jump into the next example over here. So here we're actually getting into some of the YTT functionality. As I was mentioning earlier, YTT uses YAML comments to store the metadata. So here is a first example of this metadata. What it means is that YTT will see that there is a pound @ as a comment, and it will see some particular value to the right of that. To YTT, what this means is you're trying to assign a Pythonic value to this particular, let's say, a map item, right? So as you can see over here, none, which people who are familiar with Python would know that it's equivalent to nil. So that's what it shows up in YAML. Same thing for a few other things, like for example, booleans, true and false. Know that they're capitalized because that's how Python world does it. We have integers and floats that this language, embedded language, supports. Strings, of course, are double-coded over here. and a few other more complex values, like for example, maps and arrays. And of course, you can mix and match any of those things, putting maps into arrays and whatnot. So as you can see over here, all of that stuff translates into proper YAML. Now, one aspect to this, and this is some of the wins that YTT gets you, is that because these are Pythonic values, these values are passed down directly to the YAML serializer at some point at the end of this procedure. And YAML serializer will know how to properly serialize the content of those values based on their types. So for example, over here, we have a value that has a pound sign in it, right? And of course, if we would not properly escape it in the final YAML, then this would actually not translate it to anything. This would be a key that has a nil value, right? In this particular case, because YTT knows that this is a string value, it will actually pass that down to the YAML serializer, and YAML serializer will, of course, realize that it is a string and actually quote it properly, right? So quite a few issues that different other YAML tools run into different other YAML templating tools run into is how do you avoid as many escaping and ambiguity problems as possible, right? And by using YAML structures directly, we don't typically see any of the common problems that people run into with this kind of tool. All right, so moving on to the next example so we saw that how we can use the data types directly. Well, since this is a proper programming language, we can actually assign values to variables and then use those variables later, right? So in this particular case, we have a sum list variable that also contains another variable, my map, and that's been assigned to some particular map, and ultimately it gets used as a value to list with a map. And as you can see on the right over here, we do see the result of that stuff being serialized as plain YAML. Now, variables are themselves fairly boring. So let's see how we can actually do some of the conditional logic in with YTT. So here is a basic example. You can write a conditional statement, wrap it around the particular YAML data structure. In this particular case, it's a map item, right? So key 1A. And then we got to close this conditional. And this conditional, given that it evaluates to true, shows up over here on the first line. However, if we go ahead and change that to false, it no longer shows up. There is no key 1A. Right now, of course, because these are YAML structures, you may actually want to have multiple of this keys and values and all kinds of different things going on here. So as you can see over here, it understands that this entire section, right, is applicable for this conditional. Now, there's a little bit of a sugar that we added to YTT in this programming language. There's a little shorthand, if/end. And what that means is that this conditional really only applies to the next YAML structure. In this particular case, it's a map item, right? So if I have one below it that is not going to be captured by this conditional. So as you can see over here, it shows up on the right. And then if we would flip this to false, then it will not affect the key 1B2. Now, that's all fine games, but at some point, because quite a few applications may want to have some kind of a nested conditional logic and whatnot, you may want to end up nesting them. And as you can see in this more complicated example, it does work. You can nest as many of these things as you want. Use the regular else and else ifs and whatnot. And to the right over here, it does evaluate correctly. You'll have me trust me on that if you're not reading it too closely. So that's conditionals. Quite boring. And as you can see, all of this metadata that we place into the comments isn't really particular to YAML itself. It's just a plain programming language. I think Nima already mentioned that it's based on Python. More specifically, we use a project from Google called Starlark. That's the same language that's used by Bazel, the build tool. We did have to modify it a little bit to support non-white space scoping rules. The reason why is, with YAML, given that you're already placing this programming directives within the comments, there isn't really a lot of opportunity to rely on white space to indicate, how nested things are. And hence, we had to add an end directive to be able to close different scopes and to be able to deal with nesting and whatnot. All right, so jumping real quick to 4, we slowly getting to more interesting things. So, for example, a loop that you may want to run in your template for whatever reason. Here's a basic example of looping from looping to 0 to 9. It's just going to repeat the same item in the array because it's YAML. You can have you can have any kind of structure going on over here. Similar to the conditionals, right? The programming language understands that this for loop is actually over this entire covered section. And there's also a little bit of sugar as well available. So if you do for end, then it again applies to the next YAML structure, which in this particular case is an array item, right? So anything inside that array item will be looped over. All right, and then there's a few other examples over here that may be of interest where we're looping through different types of data. The language itself, Starlark, isn't a typed language, so you can fairly easily define different data within the template fairly quickly. So it's convenient for to be used in the configuration context. All right, and then function. That's some of the juicy stuff already. So it's quite essential, I guess, when you're dealing with a lot of configuration to be able to modularize that configuration such that there is less repetition. Some of the business logic can be consolidated in one place, and YTT, in my opinion, really shines at that. So here is an example of a plain function that you can define that just happens to return some basic data out of it. This is probably less of an interesting use case, but it is possible to do. So as you can see over here, 1, 2, and key value is a value for the simple key now, right? Here it is on the right. But what's more interesting is you can define functions that just have YAML structures in them. And as you can see over here, we have a map, and this map has fairly complex, I guess, values inside of it, an array and a string. And then you can just use this function. You can call this function directly. And of course, you can call this function as many times as you want. And it will be returning a new copy of this return value every time, right? Now, with functions, of course, they would be fairly useless if you couldn't parameterize them. So if I wanted to add a variable over here, let's say name, and I wanted to add, I don't know, Max over here, Tom, Jenny, you should be able to use that. And as you can see, the result of that is each one of those structures has a different name value in it, right? So you're able to customize any part of this YAML chunk as if it's not inside a function. So it really leads to some of the nicer refactoring choices that you can make now in your templates. And given that it's all dealing with the YAML structures, you don't really have to worry about escaping and all kinds of other things that you have to do. For example, you don't have to do any kind of indentations or anything like that, since we're not dealing with text. So this is kind of the basics of YTT, right? And you can see how you can start building some of the stuff around it. To give a more actually, let me first jump into this example over here, and then I'll give a more concrete example that's somewhat Kubernetes specific. As I mentioned, or actually as Nima mentioned before, one of the features of YTT and most of the other templating libraries is an ability to inject some data into this templating environment. And this data may be anything, right? It, for example, could be some kind of a configuration values or whatever you really want. But it is important to be able to do this injection, because otherwise your templates would just result in the same thing every single time. In this particular example, for whatever reason, someone wanted to expose a set of values to be injected into this template, right? And the way that one says, hey, these are the values meant for injection, is by adding this annotation to this YAML document. Note over here is actually this probably the first example that shows this. This metadata that's being attached is actually being attached to the entire YAML document, right? So in our case, we've seen that annotations are attached to like if conditionals and whatnot, to individual map items and array items and whatnot. This one is actually applying to the entire YAML document. So in this particular example, this entire structure is being injected in, and you're able to access this structure in your other templates via this data library. And more specifically, you're able to access it via data values point of entry over here. And you can, of course, access individual things like my map over here, and let's say, key one maybe or something like that. And you can pull out individual things out of this thing, right? So for Helm users, for example, you can compare this to having access to your values YAML, and it's a little bit, different in a sense how you access it. There is no global variable that's being set. You do have to import it explicitly. So any template that does want to use this injected values has to import this data library and then use this call. But we feel like it provides enough value to to support this kind of style of injection. There's a few other, I guess, topics that we do have in our playground, but let me show a basic application, an application that well, actually, so let's see where we are. That is an application that you deploy to Kubernetes. It has a few different configuration directories over here, because we typically use this application for showing how to go kind of from a more simplistic configuration to a more complex configuration. But we'll jump immediately to this one over here. So this application is a simple hello world app that just prints a hello world when you access it over a particular port. But let's take a look at its config YAML file and see how YTT features are being used over here. So the first thing to note over here, it's loading a data library, and that it means that down the line somewhere it's going to be using either data values, or it's going to be using some of the other data library accessors to access some data that's being injected. The next thing that we see over here is we see that we define a function called labels, and labels is literally returning a single map item that's a simple app and then an empty string. Now, for Kubernetes familiar people, they'll probably already know what this function is going to be used for. It will be used for service and a deployment label selector. And what's convenient here is you can call this function multiple times, and that way you're able to reuse the same label selector for multiple places. So unlikely that you will screw it up in one place and leave it for the other places, right? So there's one small benefit out of it already. Kind of looking over here, we have a service object and we have a deployment object. And for service object, we do inject service port and application port data values. Now we'll talk a little bit more in a second why we're doing that. But here's another last thing that we're injecting into this file is data values hello message. And this is just a value for a hello message environment variable that ultimately is read by this application that's in a Docker image. And so let's see what's in the other file. There's only two files. There's config YAML and then there's values YAML. So in the values YAML, we have these three data values that we just saw being used in the config YAML. We have a service port, app port, and hello message, right? So these are the configuration knobs, effectively, for our application that someone decided to expose, right? Now, this is, as Nima was mentioning, you can kind of view the roles of some users. You can kind of separate them into two categories: configuration providers and configuration consumers, right? So I, as a configuration provider who's writing this app, who's maybe delivering this app to some people, decided that these three data values should be available to them for configuration, right? And so if we, for example, go in and execute ytt-f and then config step 2, I think that's what it was. So by default, right, because the default values are set to stranger and both of these are port 80s, right, you will see that the hello message is set to stranger, and then the ports are 80 and 80 over here, right? Now, alternatively, if I decide, because these configuration knobs are available to me, if I decide to say, hey, I actually want to set it to my name over here when I deploy this app, right? Just by passing in -v hello message, I'm able to configure what this data value shows, right? Now, and of course, if you're using, given that we're dealing with YAML over here, right? Given that we're dealing with YAML over here, I guess this doesn't like it this way. No, oh, I guess not. Oops. Well, demo failure over here. But I was gonna say somewhere we're losing the meaning over here that this is a string, but ultimately it should show up as Dmitriy. In this particular case, I don't remember why it didn't. It's actually, this might be an earlier version of YTT, so that's why it doesn't show up. So check back on a later version at some point. But that's the kind of idea over here, right? You're able to customize some of this stuff. We don't really have much more interesting usage over here of this templating language within this file. So I will talk a little bit more about the next thing that Nima mentioned that's useful to the configuration consumers. So some of the tooling out there, like Customize, like Bosch ops files, allow you to configure certain things in your YAML files outside of what's available to you as a configuration knob, right? So for example, if the provider of this YAML configuration didn't think that for whatever reason, you may want to configure the image URL, right, to something more useful, then you don't get to set it through, let's say, a data value, right? Now, of course, one way to go in and change this is to just go into this file, git clone the repo, change this file, and then deploy it, right? But the problem with that is that every time this upstream repo changes, you have to merge your files together, and I guess you have to track those changes, right? This may be okay for some people. For a lot of people, that's not something sustainable, right? Because they maybe want to be augmenting it with a lot more changes than just one. So there's a set of tooling out there that helps to deal with that, right? And it's actually allowing you to patch or overlay your own opinions and your own configuration on top of some other existing configuration. So YTT has a feature called overlays that's meant to solve some of these problems as well. It's quite similar to some of the other tooling, but it's taken advantage of YTT's ability to assign metadata to a particular set of YAML structures, and it's also somewhat more paranoid about how it's trying to merge some of those YAML structures together. So it's kind of it tries to be a lot more cautious than some of the other tools out there. So here's an example. So we have two ingress objects in this YTT playground example. One of them is called example ingress 1, and one of them is called example ingress 2. We have two overlay files over here. And as you can see, we have some metadata that we attach to the entire YAML document in both of those cases. And so the annotation over here that we have is overlay match, and we also specify how should we match or or which YAML document should we find based on some kind of a criteria over here. And then once we found one or more or zero or more documents for that criteria, let's actually apply the instructions within this YAML document. So in this particular case over here, we're saying, let's find example ingress 1, right? And by default, overlay match is fairly paranoid. So it will say, oh, I expect specifically one item to find. And if I don't find it, I will fail, right? So this is quite useful for, catching all kinds of typos, or if the upstream configuration files have changed under you, as you pull in new changes, right? You want to be able to fairly confidently say that whatever changes you have, whatever overlays you have, they continue to work, right? So as in this example over here, we find example ingress 1, which is this guy. And what we do is we remove a particular key from it, particular key value, I guess, rather, right? So previously, rewrite target was equal to a slash, and now it's no longer equal to anything, right? So annotations over here in this example, config one YAML, it's entirely empty because we've removed everything. In the second example over here, we have slightly opposite scenario. We have let's find the example ingress 2, right? And let's add 2 more annotations to it, right? Currently, overlay match, again, is fairly protective. So it will say, hey, I didn't find it. I will blow up. So we have to specify, hey, this annotation or this key value pair is missing, right, based on its key name. And so it's okay if it's missing in the original document. Right now, if we, of course, remove this missing okay, then if we scroll up over here, it will say that it can't find it. So expected number of match nodes to be 1, but was 0. So it's going to complain, right? And of course, this is again useful to be able to catch upstream changing under you, or maybe you're making a typo and whatnot, right? So going back to our realistic example, so we have config step 2a overlays. So given our file over here, right, with a service and a deployment, we have one more file that maybe this app's consumer can create on their own and finally add as their way of configuring this application. And as you can see over here, we're saying, hey, let's find an object of kind deployment, and then let's add a replica count to it. And so this is something fairly common, I guess, users want to do, right? They have different set of scaling concerns in their own environment, right? So a lot of people may want to scale up, maybe a bunch of other people may want to scale down, right? So there's no correct answer for everyone. And hence, instead of exposing a configuration knob in the templates themselves, one can just say, hey, I want to change this, and this is something that they can they can rely on as well. So to give you a live example over here, assuming that we have our YTT running over here, we can just throw in our overlay file over here, and it's going to be custom scale, and it applies successfully. And as you can see over here, suddenly now our deployment has a spec and replicas equals to 3. And to give an example of what will happen, for example, if if you're gonna go in and change this over here, right? We change this to 4, and then of course it changes it to 4, right? So overlays provide an alternative way to how you can customize your configurations, especially the ones that you don't own, right? So you're pulling in base configurations from someone else. So it's quite powerful way of doing management. Well, I think this kind of goes over quite a few examples. Yeah, I think Calvin, you were saying something?
I was just going to say, so that means you can parameterize or templatize anything from the inherited configuration. They don't have to specifically anoint something as being parameterized.
Right. It's it depending on the complexity, right? It definitely becomes easier to customize some of this YAML configuration, right? Of course, if some of the upstream authors of YAML configurations provide you a configuration knob through a template value,
right,
through a data value, you may consider using that, but it's ultimately up to the consumer to decide how they actually want to tweak it, and overlay functionality provides them with that option. Yeah. I think that's pretty much it for most of our demos over here. I think I don't see anything too exciting over here in the demo space. I think maybe one thing to take a look at is this example over here. Dig in maybe a little bit on your own time. Kate's Helmish example, as we call it. What it shows is a chunk of Helm chart that's been converted to use YTT templating. Nice. And it shows you, how it may look like. It's not necessarily following all of the conventions that one would use with YTT. For example, some of these values that are configurable, in my opinion, shouldn't be configurable. For example, users should just write the overlay files. But we've tried to keep it as kind of one-to-one as possible. Yeah, that's kind of an example that showcases your basic usage of YTT.
Okay, so we don't. I just want to kind of close with one question, which is the name of this tool is the YAML templating tool. It's not the Helm templating tool. So that says to me that the potential applications of this tool are broader than the Kubernetes and Helm space. Can you paint a picture of some potential other areas where this might be useful?
Yeah, we actually even threw in a tiny little list over here. Both Nima and I, we worked on Cloud Foundry and Kubernetes for some time, so we've dealt with a bunch of YAML configuration. At least as part of our jobs, we had to deal with YAML when we use Cloud Foundry Bosch, when we deploy Concourse pipelines for CI/CD, Kubernetes, of course. But it ultimately, as you just said, it's a generic tool. So any YAML you have, you can templatize it and use overlay features with it. At least from my experience, that's the most of the YAML that I've dealt with in those 3 projects. But there might be more out there.
Terrific. And we mentioned this briefly, but let's close on people that download this tool and start trying it. Where are the places that they can send feedback to the two of you?
Yeah, I think Nima was mentioning earlier that we've actually received the approval on having our own channel in Kubernetes Slack, so you can join us there, K14S channel. And of course, GitHub is always open to file issues or PRs or ask questions there. Yeah.
Terrific. And once again, folks, I will encourage you to look at that first link in the description field below the video player. That'll take you to the event page for today's video, and all of the important links I just added to that page about 10-15 minutes ago. So you don't have to remember any of these links. Just go to the event page, and that'll get you to the GitHub repo, a blog post that introduces this in a little more detail, and everything that you need to get started with the YAML templating tool. So with that, we'll wrap up. Nima and Dmitry, thank you for giving us your time today.
Thank you for having us.
Thank you very much.
All right, take care now. Bye-bye.
Bye.
Bye-bye.